This is video 1C for the Year 12 Mathematical Methods course. In this video, we're going to cover the theory behind the chain rule under the topic of differential calculus. Specifically, we're going to explore when to use the chain rule, how to use the chain rule, and then we're going to cover some example questions. So in our last few videos, we covered what are called the basic rules of differentiation. And when you went through that chapter, you may have come across some questions where you need to define the derivative function of something like this. F of x is equal to 2x plus 1 squared. When you do something like this, you would have expanded, simplified, and then found out the derivative from that. So f of x is equal to 2x plus 1 by 2x plus 1. Making this expansion is going to get us 4x squared plus 4x plus 1. So then figuring out the derivative function from this is relatively straightforward. This first term here is going to turn to 8x. The second term will be 4. And then the last term, because it's just a constant, isn't going to have a derivative component. So this here would be our final answer. And when you're dealing with questions like this one here, as we just shown, is a relatively straightforward one. The expansion, the simplification, and then the derivative step are all relatively easy. But then the question is, what happens if you get asked to figure out the derivative function of something like this? Let's do the exact same 2x plus 1, but let's raise the power a little bit. Let's raise it to the power of 4. Now, realistically, this is still doable, but the only problem is, it is going to take a total of 24 multiplications and then simplifications to get it in the form of a standard polynomial. And that's all well and good, presuming that 1, you can do that in a very, very time efficient manner, and 2, you can be certain that you're not going to make any silly computational errors, which when you're doing 24 multiplications is more than likely, no matter how good you are at maths. And, let's take this even a step further. What happens if you have f of x is equal to 2x plus 1 to the power of 10, or 100, or anything of the sorts? My point is, we can't always rely on expansion and simplification when you're doing these kinds of functions, because it's going to be a very time inefficient method, and again, the likelihood of you making any form of mistake throughout that entire process is relatively high. So we need to try and come up with a different method of tackling questions like this. Furthermore, you may get presented with questions where you need to figure out the derivative function of a radical function that could look something like this, where instead of just having an x underneath the square root, you now have a particular function under the square root, or even a reciprocal function where you have an entire function underneath the fraction. Because in these cases here, we can't simply apply the basic rules of differentiation, because those only apply when you have an x by itself with a coefficient. So in order to tackle these types of questions, over time mathematicians developed what is called the chain rule. Now the chain rule is a very, very important rule when it comes to differential calculus, and one that you're going to be using quite a fair bit throughout the entirety of this year, so it's very important that we get this right sooner rather than later. Now, essentially what the chain rule deals with is when you have a function in the form y equals some function, let's call it f of x, all being risen to a particular power. So as we've just seen there, we could have a situation like 2x plus 1 to the power of 4, or we could have x squared minus 1 to the power of 10. We could even have reciprocal and radical functions, because as we know about reciprocal and radical functions, we can write them instead as something to the power of something. So for example, we could have 3x squared minus 2. This could just be written as 3x squared minus 2 to the power of a half. Or we could have a reciprocal function where we have 1 over x squared plus 3x minus 1. And this could then just be rewritten as x squared plus 3x minus 1 to the power of minus 1. But my point is, we are always going to use the chain rule when we have a particular function being risen to the power of something, because we can't use the basic rules of differentiation to figure out the derivative function. And in a very, very mathematical sense, what the chain rule says is that if you have this function here, y equals f of x to the power of n, then the derivative function, whether you want to call it y dash or dy by dx, is going to equal to n multiplied by f of x, all being risen to the power of n minus 1, multiplied by f dash of x. Now let's think about what this actually means, because there is a nice worded version of this rule as well, which you may prefer rather than the equation, but it's up to you to determine which one you prefer. So what we're doing here is we're grabbing this power of n and we're pulling it to the front. So that's what this one here is. And as per the normal rules of differentiation, when we pull that constant to the front, we are now subtracting 1 from the power. But when we do this, we have to do one extra thing in comparison to when you just normally do the power rule. We now have to multiply the entire thing by the derivative of this inside function. So essentially, if you understand the normal power rule, this is just a nice extension from that. And the way that I was always taught to remember this is through a sentence. The derivative of the outer function times the derivative of the inner function. Because what you can kind of see is happening is we're essentially first of all taking the derivative of the entire thing. We pull the power to the front and then we reduce the power by 1, but then we multiply by the derivative of this inside function. So it's the derivative of the entire outer function times by the derivative of the inner function. So like I said, it's completely up to you whether you'd prefer to work with the equation or the worded version, but it's good to know that you've got both of them when it comes to your revision. Let's go through a few examples of how we could apply this rule. Now, I'm just going to write up the formula for the chain rule up the top here, just then we've got it in the back of our minds. So we've got y equals f of x all to the power of n. So then y dash is n f of x to the power of n minus 1 multiplied by f dash of x. So let's have a look at a few examples. Question A. Let's say we've got y equals 2x plus 3 to the power of 2. Nice simple one. Realistically, we could very easily do this one by just expanding and multiplying out the brackets and then simplifying from there. However, let's use the chain rule just to make our lives a little bit easier. So in this case, y dash, we're going to bring this power of 2 to the front. So we've got 2, then 2x plus 3. Then we reduce this power by 1, so it'll just be a power of 1. But then we need to multiply by the derivative of this inside function. The derivative of 2x plus 3 will just be 2, so let's write that out there. Now this is a really, really important thing. When you are applying the chain rule, and when you're applying a couple of the other rules that we're going to look at in a few of the future videos, in your exam, it will tell you very, very blatantly whether you need to simplify your answer or not. If you are told not to simplify your answer, then you could just leave your answer exactly like this and you'll get awarded full marks. However, in other situations, it will benefit you just to simplify it a little bit. So we're just going to go about doing that. Not going too excessive, but we're just going to simplify it at least a little bit. So we've got 2 multiplied by 2, so that can get reduced down to 4. And then the 2x plus 3 all to the power of 1. Well, power of 1 is meaningless, so we'll just leave it at that. Question B. Let's say we've got y equals 3x squared minus 5 all to the power of 10. So this is one of those examples from before where we couldn't really use the whole expansion and simplification method feasibly with this one because it would just take you way too much time and you're most likely going to make a mistake at some point along that process. So this is where the chain rule will be significantly easier to use. So once again, y dash, we're going to bring this power of 10 to the front. So 10, 3x squared minus 5, reduce this power by 1, so that'll be now 9. And now we need to multiply by the derivative of this inner function, which in this case is going to be 6x. And again, if we wish just to simplify this a little bit more, we've got 10 multiplied by 6x, so that'll be 60x, and then we've got the 3x squared minus 5 to the power of 9. And we can just leave our answer like that. Alright, question C. In this case, we're going to have a reciprocal function of 7 divided by x minus 1. So similar to our discussion of when we use the basic rules of differentiation, when you have a radical or a reciprocal function, the first thing you need to do is rewrite the function in a power form. So this can be rewritten as 7, then brackets x minus 1 to the power of minus 1, because it's on the bottom of a fraction. So now that we've got in this format here, we can now use the chain rule. So y dash is equal, we'll pull this -1 to the front, so -1 by 7 x minus 1, then we're going to reduce 1 from a power, so that'll be minus 2, then we need to multiply by the derivative of the inside function, which in this case will just be 1. Now, again, let's simplify a little bit. -1 by 7 by 1 is -7, then we've got x minus 1 to the power of minus 2, and like we discussed in the previous video, it's always a good habit to switch back and forth between this format here and either a radical form or a reciprocal form, depending on the question that you're talking about. But in this case here, it would be -7 divided by x minus 1 squared. And then finally, part D, let's do a radical one in this case. So we've got y is equal to the square root of 5 minus x cubed. So as per the last question, the first thing you need to do is rewrite this in the format of a function to the power of something. In this case, it will be 5 minus x cubed, all to the power of a half. Now we can apply the chain rule. So we're going to bring the half to the front. So half, then 5 minus x cubed. We'll reduce 1 from a power. So a half minus 1 is minus a half. Then we need to multiply by the derivative of the inside function, which will be -3x squared. Let's simplify this a little bit. A half multiplied by -3x squared is -3 over 2x squared. And we've got the 5 minus x cubed to the power of minus a half. And now we want to just practice a little bit in switching this now back into a radical form. The power of a -1/2 will turn it onto the bottom of a fraction, then square rooted. So this is going to be the same as -3x squared over 2 root 5 minus x cubed. And that there is the chain rule. Once again, this is a very, very important rule to get your head around. You're going to be using this quite a bit throughout the course of this year. So it's very important that you understand how to implement this rule. And that, as per usual, is just going to come by practicing a lot of these different types of questions. Alrighty, let's wrap up. So in this video, we were introduced to the chain rule, and how we can use it to differentiate a function risen to a power. For example, 3x squared plus 4, all to the power of 5. The chain rule states that for a function y equals f of x all to the power of n, then its derivative, y dash or dy by dx, is equal to n multiplied by f of x to the power of n minus 1 multiplied by f dash of x, or in other words, the derivative of the outer function times the derivative of the inner function. The chain rule can also be applied to reciprocal and rational functions with the use of the following index laws. 1 over f of x to the power of n is equal to f of x to the power of minus n, and the nth root of f of x to the power of m is equal to f of x to the power of m divided by n. Finally, we saw how we can use the chain rule to answer exam-style questions. And that's it for now. See you in the next video.